Hey everyone. So in our previous video we have covered the packet switch networks. As moving forward in this one we are going to discuss reference models. A reference model is a conceptual framework that standardized network communication by defining functions, entities and interfaces. It also deals with how communication functions should be organized into layers. A reference model provides a common language and a framework for understanding network communication and to design protocols. Each layer in the reference models has a specific role and provides a particular service to the layer above it while using the services from the layer just below it. Reference models are mainly used for certain purposes like standardization. They provide a standardized way varying architecture and operating systems for communication between devices and systems. Conceptual understanding. They give a structured way to understand complex processes of network communication by breaking into smaller and manageable layers. Problem solving. Reference models provide a common language and a framework for network professionals. There are mainly two types of reference models which are you can say popular or more often used. The first one is OSI reference model. The OSI stands for Open Systems Interconnection Reference Model. It is a conceptual framework developed by International Organization of Standardization, that is ISO, in 1984. It is a 7-layer network communication process to standardization of network. It specifies how the information from one computer software application moves through physical media to another computer's software application. As we know, OSI reference model has 7 layers. In that, the very first 3 layers are known as software layers, and the last 3 layers are known as hardware layers. Meanwhile, the middle layer, which stands in the entire middle of the OSI reference model, it is known as transport layer. It is also referred as the heart of OSI model. So this is the diagram. You can refer for better idea. You can also draw this diagram if the reference model or OSI layers question is asked in your exams. So the first one is application layer, next presentation layer, next session layer, transport layer, network layer, data link layer, physical layer. Here the sender moves from application layer to physical layer. Meanwhile, the receiver moves from physical layer to application layer. They both move in opposite directions. The first 3 layers are known as software layers, we have discussed earlier. The last 3 layers are known as hardware layers. Meanwhile, the middle one, transport layer, is known as heart of OSI. Let's discuss each layer. The first one is application layer. It is the closest layer to the end user. It acts as a direct interface between software user and the network. It produces the data that will be sent and displays the information received from other layers. It uses numerous protocols that are used for different purposes. It generally uses HTTPS, SMTP, FTP, DNS, etc. All these are protocols. It allows the users to access and share files and send emails, etc. In this layer, the information or data is known as data only. But in the remaining layers, the naming or the data is referred in different names. The next one is presentation layer. This layer mainly concentrates on syntax, semantics, etc. of the information exchanged between systems. It is also known as translation layer. It ensures that data is formatted, secured and compressed so that the receiving application can be correctly interpreted. It extracts data from the application layer and converts it into a standardized format for the network transmission etc. purposes. Here also same. In this layer, the information is known as data only. Third one is session layer. This layer is responsible to establish, manage and terminate the connection between applications. It ensures that the communicating parties are verified and the connection is secure. It inserts checkpoints into the data stream, which allows a transfer to resume from the last saved point. If a failure occurs, rather than restarting from the beginning, it can be helpful to start from the particular saved point or checkpoint. It acts as a dialog manager, governing the opening, closing, and security of communication channels between two devices. In this layer, the information is known as data, just as same as application layer and presentation layer. The fourth one is the middle layer, transport layer. This layer is responsible for the end-to-end delivery of entire messages. It splits large messages into smaller segments for transmission and reassembles them in the correct order at the destination. It has to maintain the order so that the data can be received in the same sequence as it was sent from the sender. It uses protocols like TCP and UDP. It provides both connection and connectionless services. It has to ensure the reliability, error checking, and flow control, etc. Here, the data is broken down into segments, and the data or the information is named or be called as segments instead of data. The next layer is network layer. This layer provides communication between host and different networks. It assigns unique IP addresses, sender and receiver both, to the packet header to identify devices globally. It determines the most efficient physical path from the source to the destination across interconnected networks. It divides the data received from the transport layer into packets, and in network layer, the data or the information is named or be called as packets. But just the previous layer, we have said that the data is called as segments in the transport layer. But coming to the network layer, the data or the information is called as packets. The next layer is data link layer. It serves as the bridge between physical hardware and the logical network. It ensures the node-to-node reliable delivery of data. At this layer, data packets received from the network layer are divided into manageable units called frames. The DDL uses MAC addresses for physical addressing to identify host, and it encapsulates the senders and receivers MAC addresses into the frame header. It, it further has some sublayers like logical link control LLC and MAC media access control. LLC, logical link control, it manages flow and error control while acting as an interface for upper layer protocols. MAC, media access control, it determines how devices physically access the transmission medium and handles hardware addressing. The DDL layer is responsible for error control, flow control, and access control. In this particular layer, the information or data is known as frames. The last seventh layer, that is physical layer. It is the lowest and foundation layer of OSI model. It acts as the bridge for actual physical connectionless between devices. Its primary mission is transmission of raw unstructured bit streams over a physical medium from one node to next. Common devices operating at this level include hubs, repeaters, modems, and cables. It ensures the sender and receiver are in sync by providing a clock signal that controls the timing of bit transmission. In this layer, the information is known as bits. So the workflow or the flow of data happens in this particular way. In OSI model, the data first goes through the application layer, then to the presentation layer, then to the session layer, then to the transport layer, and then to the network layer, and that finally it reaches to the physical layer. So till now we have completed what is meant by OSI model. It has 7 particular layers, and what are the functionalities and features of each layer, and what the data is called in particular each layer. So first 3 are software layers, last 3 are hardware layers, and in the very first 3 layers the data is known as data itself only, but coming to the last 3 layers, the data is called in different names like bits, frames, segments, packets, etc. So the next or the second type of reference model is TCP/IP model. It stands for Transmission Control Protocol slash Internet Protocol model. It is a practical networking model that defines how data is transmitted across networks, including the internet. It allows communication over long distances possible between two devices. It specifies how data should be packetized, addresses, transmitted, routed, and received on a network by providing end to end communication. It is simpler than OSI reference model as it has only 4 layers. But in the OSI model, there are 7 layers. Meanwhile, in TCP/IP model, we have only 4 layers. Those are application layer, transport layer, internet layer, and network access layer. Let's start from top. Application layer, the top layer of TCP/IP model. It is closest to the user. It is responsible for node to node communication. Applications like web browsers, emails, clients, and file sharing tools interact with the network. It provides an interface between user software and the lower layers. It supports protocols such as HTTP, FTP, SMTP, and DNS. It also handles data formatting so information is correctly understood by the both sender and receiver. The next one is transport layer. It provides an end-to-end communication and how much data should be sent, when has to be sent, where has to be sent, and between processes. The transport layer controls all these particular functionalities and it decides between which processes all these functionalities has to be happen. It is similar to the transport layer of OSI model. It breaks large messages into packets and reassembles them at the destination, prevents the receiver from being overwhelmed by regulating data flow. Here both TCP and UDP protocols are used. TCP checks for errors, resends lost data, and ensures correct order. UDP provides low latency, connectionless delivery while error checking. TCP stands for Transmission Control Protocol. TCP is used when reliability and accuracy are more important. It ensures that data is delivered exactly as sent. Meanwhile, UDP stands for User Datagram Protocol. It is used when speed is more important than perfect accuracy. It is faster but does not guarantee the reliable delivery of data. The, the third one or the third layer in the TCP/IP model is Internet model. It is responsible for addressing, packaging, and routing data packets so that they can travel across networks and reach the correct destination device. It is also known as network layer. Internet layer's primary function is to send packets from source to the destination regardless of route. It assigns IP addresses to identify source and destination devices. It breaks large packets into smaller ones for transmission and reassembles them at the destination. Primarily, it uses IP Internet Protocol along with supporting protocols like ICMP for error reporting and ARP for address resolution. Network access layer or link layer. It is responsible for physically transmitting data over network hardware, including cables, switches, and wireless connections. It sends and receives raw data bits over physical media like Ethernet cables, fiber optics, or Wi Fi. It organizes data into frames for proper transmission and recognition by devices. It deals with framing, MAC addressing, error detection, such functionalities. So, this is all about the reference model. So, the summary of this video is what is mean by reference models. There are two types of reference models, that is OSI reference model and TCP/IP reference models. And then we have discussed what is mean by OSI model, what are the number of layers present in it, and features and functionalities, characteristics of each particular 7 layers. And then what is mean by TCP/IP model, what are the layers present in it, and what are the characteristics and functionalities in each layer of TCP/IP model. So this is all about this video. I hope you have understood this concept. Keep learning.